So, hello and welcome to our webinar about layer integration with Production Assist and SCAD Re-event. So today's webinar is about learning on how to draw layer structures and how to calculate them. The realistic goal that you can have with this is actually that you can do the calculation on any kind of layer structure that you have. I have two examples in here from our engineering office. So the Production Assist tool is especially useful during the design process of such a stage or structure or PA tower in order to actually check if the structure is viable. If you are then an engineer and want to put it forward in the reporting part with all of this, it's also possible to create beautiful reports with all the things that you see, how everything needs to be built and stuff like this, to send this to the interested parties in this. But it's also possible to put this part of the calculation out to our engineering office in here. The important thing, the webinar is structured in 3 parts. So first, I will go over a little bit the integration with SCUT. So how to install it, what to respect, and how to connect Production Assist and SCUT in here so that they properly work together. Then Bert will take over. He will show you how to draw the scaffolding structures with SCAD real fast. So there's a lot of functionality built into the SCAD that actually helps you draw the structure, even special structures in here, and to be really fast. And then when he has shown you how to draw it, we will actually show you a little bit more on how to calculate it in there. So that's a little bit the splitting with this. So for this, I will turn off my video because I now need to move to another computer, and let me share my screen on the actual, where we have it, on the actual second desktop in here. So now it's shown. So SCAD Re-event is a program that I just started. It's really, really similar like AutoCAD or Brick SCUT in here. So it's DWG based. So really compatible with a lot of other platforms, and it's a really good drafting tools in here. The relation between Production Assist and SCAD Re-event is that we have a special plugin for SCAD Re-event, or the base platform Brick SCUT, which is using, that actually integrates all the functionality of Production Assist directly into SCAD. The way how you're doing this, so how you get this, is basically you need to go to the Production Assist web page, and therein you have the download. You need to download just the Brick SCUT plugin in here.
Oh.
So with this Brick SCUT plugin, you actually can then use it. So I already downloaded it. So I put it into, where do I have it? Into the download folder. I have a folder in here, which is called 1.12.8 production Win Brick SCUT in here. That is basically the file that we need. And in order to load something into Brick SCUT in here, you need to use an appload command. Appload basically allows you to load extensions. So when I'm loading this extension in here, it shows me all the application files that I can load. I already have checked this here in the download one that I want to use. And when I open this the first time, this will be empty. So I need to click on plus, and then here navigate to the actual, where do we have it? No, home, downloads, wherever it is. I think it's this in here, and then I would need to go to Production Assist. Then depending on the Brick SCUT version that I need to use 24, 25 or something like this. Selecting 24, and then in here, just selecting this library. I already did this, and so what I do is I need to click on the load in here. Once I'm loading it, you will see that it's actually putting some stuff into the command line in here. There's also the possibility to auto load the plugin. So right now, if you only load this, you need to do this after every startup. If you want this to be automatically loaded once you start up SCAD Re-event, you just need to check the auto load button in here. So Now when I'm doing the close button in here, I basically have everything in here that I need already in here. So if I'm click on the console in here, I already saw that there is something. One thing that you will notice, it will add a production assist ribbon to the SCAD Re-event workspace. The production assist ribbon basically allows you to change specific settings in here with this. So maybe the first one that you want to do is you click on Open App, and then it will start the desktop app that you have, that you also need to have installed on your computer. So the connection between then the Brick SCUT and the app is really simple. You just click on the bottom right and click on Plugin, and then from there on, these two things are connected in here. And I just put them next to each other. An important thing that you need to know is that by default, production assist is disabled in here. So it will not read in the calculation with this. The easiest way to do this in here is to add something. Just use a really simple thing for something like a truss and add them in here, that we can add these trusses in here. And you see they don't appear in production assist. In order to do this, wait, I just mute everybody. Do I have this in here? Sorry for this. I'm adding this. So now in order to read this in here, I click on Enable Production Assist, and then it will read in these two things in here. So when I'm now searching for it, I actually see that the truss has been read into the Production Assist thing. As it currently does not have any supports, we can't really calculate it. I can do a little bit of trick that you're already getting some glimpse of what we're going to do. So I'm just faking a little bit. So I'm using spindles now. So I'm putting the truss on spindles in here. So putting in 4 spindles with this, and terminating the thing will actually bring this in. And then when you're doing this, you will actually see that the calculation from this is already there. The easiest way to see the calculation then in SCAD is to go to the production assist layers that you have. And in here, for example, you can show the deflection DU. And in here, what you see with this is that it's really reading all the internal members and actually calculating all the different beams, bracings, and tubes separately in here. When we now come to the layer stuff with this, we will also use this kind of things, but step by step in here. So that's basically the first steps of integration that you need to do to get SCAD Re-event speaking with Production Assist. Maybe last time that you have something in here, maybe that's a little bit more interesting. So it will also show you the workload. In here, currently there's no load, so it's not overloaded at all in here. So if I would now make the truss a little bit heavier, for example, so maybe give it a weight by 900 kilos, you will see that the deflection, oh, it's still okay. So let's do like 1,500 kilos each. And then you see it's starting to get overloaded here in the middle, which is not really well displayed, but there's maybe not that much with this. So with this information, Bert, are you ready to take over from this kind of thing?
Yes, I'm ready.
Perfect. Then I stop sharing my screen and you can share your screen, Bert, and please give us a short introduction about how to do something like this.
Okay, this is the same SCAD screen as Moritz showed you. SCAD Re-event is, like Moritz said, a program to design events. It's not just scaffolding or trusses, but also events, festivals, and so on. But I'm going to show you, we are of course focusing on the connection between SCAD Re-event and Production Assist, but I give you a fast glimpse of what you do when you create structures, stages with layer, what additional checks you can do to be sure you have the right list of items, and also, of course, the structural calculation. When we work with scaffolding objects, I can insert them in the drawing. Let me switch to a realistic view. And the key thing is we added points on key positions that if you work with an entity snap with just points, it's almost impossible to miss by snapping the objects even when I'm far away, and I go to my standards and I click a random one. If I click here, it's always the right one. Even when I go to ledges like this, it's connected to the point, and what a key part of SCAD is I can rotate them before I can click them, so I'm really fast to click stuff like this. But we also have fast commands to repeat objects, and even when I did a little bit too fast, then I, for instance, have now double objects over here. They're all checks. I will show them later. That you will always be sure that the drawing looks okay, but if I do a count list of objects, I don't want to have objects on the same place or objects with wrong connections. So now I made a little bit of a mess of the objects over here. I can copy stuff like this. I do this with the keyboard commands, which are just commands like copy in one direction. For instance, one possibility would be if I copy this in the Y direction. I did it by hand now, so you can really fast click and add objects. Also, objects like filtering, now I can easily select stuff like this and copy this to another location. And also I can do stuff like this. Now I want to let me do the normal way, or the slow way, I would say. Now my SCAD is doing a save. I can replace this a button over here. Normally I type the commands in. Is this the correct one? No. Where is my correct button? I select the objects I want to replace. Normally I pre-select them, and then I select the objects which I want to replace them. So if I need to change something in the drawing, I can do it really fast. There are also some filters that I can select partially only the certain kind of ledges to build this really fast. When I go to the next and work with braces, stuff like this, I can also easily rotate the object by clicking and then copying is the same way I did before. And if I do this a little bit too much, then I can end up, I switch to another drawing with an example a little bit like I created before from scratch. In this case, there's an error. This is not possible to have both ledges and the braces in the same slot. So I need to fix this. There's an easy command to fix this. But the main problem is, how do I find every error in a drawing? Well, there's a command. It's not a default. It's not standard in SCAD, but there's a model check module you can have, and then it will find any error in the drawing. So if I now select the ledges where the problem is, and I do the fix, I didn't select them correctly, I think. But let me check. I do the model check again, and everywhere where the connection is fixed, the error will disappear. And you can also do this by finding braces through a floor error and stuff like that. And even like this is a standard with a pen. You should have an extra object on top of it. It can find that you have used this object without anything on top. So it will point this out as an error with a different color if you want to. So there are many ways to check the drawing. And of course, in the end, you do a count list and you see every object you have used and the weight and whatever you wanted. Some other stuff, yeah?
Bert, just when you're doing a command, can you just tell what button you are clicking? Then it's a little bit easier to find out. So
Okay.
for example, in order to rotate it doing insertions, I think you need to use F8 and F9. So maybe just mention this, that helps quickly this, and also show how to get to the library. Thank you.
Okay. You're more experienced with Zoom demos as I am, apparently. Here's my library again. When I want to add an object over here, I go, in this case, I stay with a layer, BA-enabled layer part of the library. I go to the ledges, and when I click an object, it's on my pen, on the cursor, in a certain direction, and now it snaps to a point where I am with the cursor. But when I do one of the options over here, and there's one option I use a lot that is rotated 90 degrees or 90 degrees in the other direction. This is, in this case, is F9 and F10. But what it does is one or the left or the right commands over here. So it's basically the same as doing clicking on the options I have. The same happens, I delete now this. The same happens when I do a copy command. I can also rotate it by F9 and F10, but I can also copy it free. So there are many commands. Now I go to a top view, and maybe this goes a little bit too far, but when I want to copy stuff like this and I want to rotate it in the direction of a line, I can, now I'm guessing a little bit because I'm too lazy to switch to endpoint to do it correctly, but I can easily switch to another orientation. And even when I go to, when I want to work in this orientation, I can continue to work in this orientation. Now this is straight and this is in an angle, and when I go back, then so I can do the main stage and some wings in another direction as easy as everything was straight. We have a lot of commands that works with the X, Y, but when it's not X, Y, we just rotate the cursor, the coordinate system. Some quick views of what you can do. If you have a drawing like this and you have a top view, it's not easy to see what's there because every standard has a different height. So if you want to build this and you only have the top view, there's a way to make it a little bit more easy to see what's going on by having a standaardplan. It's the Dutch word. You can translate it, of course. And now you can see on this position, there's a wood bed, a spindle, a vessel, and 3 meter and 1 meter. And on the position 2, there are other options. So this is, I can do this on any, and now I start with the 3, and on.
What button do you need to click for this?
The command I select this. I really don't know where the button is. I don't gonna search in the ribbon, but the command is stplan.
Okay, perfect.
And then I if the number, I tell them what it is, and apparently I do something wrong. I see what I did. This is one block. You can use, normally you do this on separate objects, but SCAD is able to work inside a block and then use a part of the drawing and then do the same tricks without having to look at the whole drawing, which makes it, of course, a little bit more slow to work with. I do have a different scale. Probably this is in meters and the other one in millimeters, or the other way around. So now I go back to the main drawing. What I did was double clicking in the object, and now it's inside this with different scales, with probably, like I said, with different units. So this is a way to see what's going on. Another thing is that if you have a really big stage, I switch off the library and it's getting a little bit more complicated. It's really difficult, for instance, to find the errors, which you don't have to because SCAD will do it for you. Another thing is that you would like to have sections, and now I enter the command insert section. Insert section, and for instance, I want to do it in the Y direction. I also click on the points in the drawing, and it will add the character, and everywhere where I click I get a new number. This one was wrong, I was a little bit too fast. And then I go to an empty layout, a drawing, and there's a command, create section. We changed this so much that I never know where to find them in the create section viewport. It recognized that I entered 5 Y sections in the drawing, and then I click I want to have the sections in this small viewport, and then it has to add viewports as much as I need, or even add extra layouts, and I say it needs to stay within this border, and now it creates the sections from every position I had in the drawing. So you can, it will, like I said, add more layouts, add more pages, so you can create and print it pretty easily to have an overview of every section of interest in the drawing. Just a quick look to SCAD can do the stages in a festival, but you can also do the whole layout. So you can do the fencing and the numbering and even the power lines and you name it, areas, number of people. There's a lot of stuff you can add in the drawing. In the end, we like to have possible, and I think it's possible already, to have every information, even for the planning, in the drawing. The drawing is the single source of truth, and you can work with Excel together to have sheets with information which are connected with SCAD drawing, and you can build big stages like this. And the big example is, or the big advantage of this is that you can draw it, and you can draw it exactly like it is in real world. You can see a problem here with a decor, but everything in the drawing, if you draw it, then you know it's possible to create it. So back to the objects I was drawing for the static lines for the calculation. What happens here is, and now is my zoom a little bit in the way. Let me select all those layers and switch off anything that is not used in the drawing. Now I have those layers, and for instance, when I switch off the tube, you can see the 2D information which is inside of all the objects, and the wire information also. Now you see the lines that are used by Production Assist, and it knows because of the layer and the color, but probably Moritz can explain it more, knows exactly what kind of structure this is and using this for the correct calculation. So the information, the connection is real time. So also whenever when I do enable here, even when I don't know where my Production Assist is, when I switch on the deflection layers, I probably, let me check, everything is there, but the deflection here, the layer. So even when you can work with SCAD, with PA on the background, and do stuff and change stuff to see what's going on, add more weight, add more braces, or leave them out, and you can work in real time with the calculation in the background, which is really big advantage, because most of the users from SCAD now had to convert the drawing to a calculation program, see where the problems are, maybe change it, but then go back to the drawing and make those changes and send it again and do the calculation again, which is not necessary for now. So that completes a little bit what I would like to see about SCAD. Is there anything more, Moritz, You want me to?
No, I would just take over from there and go a little bit more into detail into the blue lines that you're seeing in here and put this. So thank you very much, Bert. That was
Okay.
tremendous. And so just stop sharing your screen. I think then I can share my screen. Yes, perfect. So going back. So Bert already showed you a little bit how it works with the lines. That was actually a little bit faster than I expected. So it took out the surprising factor how it works, but no worries. So let's get started. So one step after another, I try to do it a little bit slower with this. So we're building a structure and learning on how to calculate it. So the important thing, if you open it in here, there is the SCAD library. And the SCAD library basically brings you all the library that is in here. And it's a quite big library that has it. The important one that you want to play with is the layer PR enabled library. The special thing about this is that this library actually has been prepared with all the lines and all with the right properties in order to calculate this. We are in the process of adding this for all the other objects like trusses, stages, and stuff like this. But it's quite a lot of work, so give us some time for this, step by step. In order to check it, the layer PA enabled thing is already there and actually is quite powerful to do this. So when I'm now having this, I normally want to start with a spindle in here. So I start with the first tab, and there are several spindles. The one that actually is important for us is the SCAD PA spindle 60, which is the layer rigid spindle 60 with the starting piece, which I always call Snuffelstück. So that's always funny. So basically, it just the connection piece for layer so that you can start together with the other thing in here. So if you're inserting this in the drawing, you're just clicking in it and then it's in here. So you have it inserted with this. And when I now go to production assist in here on the other side, you see it is already being shown as well in here. One note, right now I have on the left side the Brick SCUT and on the right side the production assist. This is not needed. The desktop app is basically only used to show the user interface of production assist in here to change wind load and all of the stuff. So we will look into this. So it is not really needed that this is always visible, but sometimes it helps you a little bit seeing the structure in here. So now I have my structure in here, my thing. You see when I select something in Brick SCUT, also selected in Production Assist, and then the other way around. So if I'm selecting something in here, it's also selected inside the SCAD Re-event thing. So the copying thing in order on how to build this now, it's basically pretty easy. So before we start copying it, I switch a little bit the view in here that I have this, and now I go to the standards. So what we want is a typical like 2-meter piece starting with this. And now when I'm inserting it, you see in here there's an automatic snap point. So when you move over it, it basically only snaps in here. The important thing that you use for the insertion of the layer thing is the object snaps in here. So this snap to point button that you're using. And when you're activating this, it will only snap this in here. An important thing also is if you now during the command, if you now change it, then it will also select the other pieces in here. So, but this is when you're snapping layer, this is not something that you want. If I'm activating the command, you will see automatically it resets with this. So if you want to change it permanently, you need to do it without a command possible. The one thing that you see, I already have put this up in here. So the layer thing is already standing. I see the green line and I see the blue deflection line a little bit in here. So that was basically the easiest way of doing it. So the typical thing, if you select this now, is you want to actually duplicate this. So the things where Bert actually used the mouse for the keyboard for this is there are several commands in here behind of this. So what we now want to do is we want to copy it in the X direction. So the command that you're doing for this is CX and then pressing enter, which will activate the copy in X direction thing. So the easiest way for me is always now to type in the distance X. So you type in 2072. In the bottom left, you see the command line where I'm typing. So if I'm now pressing enter, it will actually copy the thing in here with this so that you have this. Every time I'm now pressing enter, it will actually copy this thing in here and will duplicate it. If I'm now pressing ESC, I will stop it. And after I stop the command, Production Assist will read in the changes. And now all of them are connected. So when I have this, I have my standards there in here. So the next thing that we need is ledgers. So built in Production Assist, there's quite a lot of ledgers, and for all of them, we can do the calculation. So if you have this kind of thing or the enforced ledger, that is always something that you need. The important thing is a 7072, because this is a distance that we actually now want in order to enter this. So what I do is I select this and now move to this. Again, I have only the point snap on and click on it, enter. And then when I'm doing this, I have this inserted in here. If I'm now using Control and the mouse key to the right, I actually just with the mouse keys can copy these things. So the other option is to use the mouse cues to copy this, and that's also really powerful. If I'm now selecting this in here and type in CY, I'm doing the exact same thing in here in the Y direction. So in here, I want to go also CY 7072, which is the layer distance, the default one, enter, enter. And then I have this in here, and you see now it's also connecting it like this and can calculate this. So next thing, oh, that was the wrong 7072. But this is now not in the right direction. So just press an F9. That was the wrong F9. So that you have it like this and then enter it. So now when I'm doing this, you see that they start connected. When I'm now going into this direction, I'm just doing the exact same thing in here. So I'm using Control and the mouse keys, the arrow keys in order to move this. Now I'm selecting this and moving them up. So now I have my first basically framework of layer that I have connected with this. And you see right away when you're doing this, you're actually directly calculating this in here. So what we now need is, that is our bottom piece in here, so that basically everything is set it up and everything is correctly. You actually see that I didn't insert it at the right height, so I need to move it down. Why is it not the right height? So maybe I did a mistake with this. Oh no, it is the right height. That's just the other thing. Sorry for this, for the misinterpretation with this. So I've set this up like this. So I have the base structure in here that is connected like this. So what I'm doing is I'm selecting this, and now the next menu command is ZZ, so copy in Z direction. So when you're building a stage, normally it is like that the first layers of layer need to be compact in order to actually undo a high thing. So when I move this now up, I only want to do this by 1000. Then enter and enter, and then I have the first two layers with the 1000 things in here. So if I now have this, you see it's also automatically calculated and done like this in here, so that you can see it and actually can change it. If you then go to the standards and actually build it a little bit higher, and now we starting using the 3 meter pieces whenever I find them. This is a 3 meter piece. So I'm inserting it in here. So 1, enter, wait. So I want to select this entity, right, 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 right. So then you have this, and then you select this and you press Control up, up, up. You see it, you copy it like this. And then maybe you want to build a little bit higher. I'm selecting this in here and do the CZ again. This is now 3 meters. I know this, so I type in 3000, up, up, and now I'm calculating it like this. So really fast, I can build up my layer thing with this. So going back to the other direction, now I'm selecting this. And when you have the first bin this compact, you now do a ZZ in here, and you want now 2 meters with this. So you type in 2 meters, enter, 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 enter. And the last one should be again 1000. That's basically for cosmetics so that it's closed. And then you see it automatically have drawn this and calculated. It is in here so that we have a nice structure that we actually can calculate. So that's basically the really basic layer structure that we have in here. So right now I always see the workload. I also do the workload on top of production assistant here. So the the ledgers have about 3% workload and the columns have about 5% workload currently in here. So an important thing that you now see in here, currently this is only supported by dead load. So there's no wind, only the dead load of the structure. So the first thing that we need to do in order to basically get in here to a reasonable level is actually selecting this so that you have it in here and tell the structure that it should use this as a wind load plane. So there's a button, use structure as a wind load, and then it will automatically actually calculate this. Wait, let me quickly also do the production system so that you see it, that it's shifting to the side like this. You can change the CF value to 1.2 in here, and then you see if this structure without any diagonals is inside the wind in here, you would end up with about 20 centimeters. I think that should be like 8 inches of deflection to the side in here in this direction. When you click on here with the wind load direction, it will actually show you that the wind is coming from the X direction. You also can change this. So if you go to the load combinations in here and change it maybe to 10 degree, then you will see it kindly sweeps out with this. And then we do 25 with this. And every time you're changing this, actually it will calculate the wind load for this and the deflection for this. Just for the simplicity, we will let it like this so that it's going to the side and it is not covered, but only the ledgers in here. And what you see in here, it actually has problems. So you see there is red because this is really deflecting here at this point. At the point where the ledgers is, there's actually a problem. So the resolution for this is quite simple. What you need to do is you need to insert the diagonals. For the diagonals, you go to the bracings, and for the bracings, there are several bracings. So the thing that you need is basically the 207 in the length and the 2-meter high. So if I'm selecting this, I can insert them in here with the first one, pressing enter, and you see it does this and changes this in here. And then I'm selecting this, now I need to copy it. So I want to copy it to the back, so I use Control and the arrow cursor up this 3 times. And then you see it already fixed this in here. So basically placing these 2 ledgers or these 3 ledgers in here already brought down the workload when you just build it like this to 93% in here. So you see that's the advantage of direct calculation with this, and actually to see what kind of changes do you need to do in order to calculate this. So the next step that I'm doing, so you see it's good enough, but it's still deflecting a lot. So I'm copying this, do CZ, type in 2000 for the copying, enter, enter, enter. And then I have this in here, and then I see actually the diagonals also go down with the actual deflection. So you see, you now have about 10 centimeters deflection in here that is actually used for this kind of thing in here. For sure, the more of these kind of things you're adding, so if I'm now using this and copying it like in here, you will actually see that this now straightens out the thing in here. And you really see what kind of what diagonals actually bring for the structure. So if there's only one diagonal on top of here, you see there is some deflection. If you have 3 of them, it really puts down the deflection in here with this. But right now, the main problem in here is actually that they don't have a bottom one. So for this, I go into the brace 207 1 meter and add this in here, and then copy it 1, 2, 3, and also moving it CZ up by 1 meter, enter, and copying it. now I have it like this. Now see, it's not that big anymore with this. So this really allows you to put in the diagonals only where you need them so that you have a proper enforcing layer construction that you can use for the calculation. And that's basically the most things that you're now doing with the production assisting. Now we have a structure that is like 63% used just for the wind load, which is standing in here, which is quite good with this. And now we want to have a little bit more look onto the wind load in here. So currently, the wind that we have in here actually only applies to the tubes, which is fine because right now we don't want to cover this. That's also possible, but one step after another. So the next thing that you do is actually checking the load combination settings. And if you click on here, there's the wind load settings. And the wind load settings basically allow you to select the locations. So for example, if you're in Germany, there are 4 wind zones where you are in. We here in Berlin are in the wind zone 2. So somewhere next to Potsdam. Funny that the big cities are not shown in here with this. And in here, there's a specific wind. The default setting for this, so if I didn't change something, is 30 meters per second, which is basically the highest wind load that you can have in Germany and also in the Netherlands. But for other things, you need to change this yourself with this. So for example, if I'm now going to 2, it goes down from 0.56 to 0.39. And then an important thing to understand that the wind itself is not blowing always with the same pressure on all the heights. So because of this, we see this in here. So basically, depending on the height, so if the height of the structure or the structure at the height 6 meters get 0.41 kilonewton per square meter wind load. And then when you increase the load, so for example, if you are at 16 meters, it is 0.33, and so it starts with this. And that is what production assist is automatically calculating. So every time you are changing this in here with the height, this is always a little bit different in here on how the wind load actually is. That's something, settings that you need to do. So that was the way how you calculate the things in here and calculate this. So a typical thing, especially with event structures, is that you need to enter actual, so where you have a DU, that you need to enter actual ballast plates. So if you want to add a ballast with this, what we will do is we need to add a ballast bay in here. So what we do is we will put only the ballast in the middle in here with this. And the easiest way to do this is to click again on the SCAD library, select the ledgers, and in here we will use one with the transom stuff. And in here I just put this in here, and then I want to copy it. So I select it and pressing Control up, and now I have it 2 times in here with this kind of thing. What I do often in here, and that's why I have this normally in here, is that in Production Assist, I do have the things in here so that I see what it's doing. Now you see it's calculating the top tube and the bottom tube and the individual steel bracings in here that you have for the things. If I'm then enabling the workload, you will actually see also the workload for this. And if you check into this, you will see the different things in here as well. So the next thing is the ballast, and for this we have some ballast steel things in here. So we need again the 207 one. I need to rotate them by 90 degree, so like this. And now I need to place them on this in here, so that they are placed on this. You see, it's not snapping. That's because I only have the point snap on here. So in this case, you use the snap to nearest. And then the important part is actually to select the right line, which in this case is this one. And I end at 1, and then I added 2. Boy, I need to click it again. And then I have my ballast bay in here. So these 2 things. You'll see they also are inserted in the other thing. So copying them is really easy. So select them, and copying up so that I have them like this. So the two things where they actually go into this, you will see that it's actually not works by this because there is a collusion. So we will select them. I do MX for move in X direction. And I want to move it. Now it's moved it farther than I wanted. So let me undo this so that it's back like this. So I want to select this, and I only want to move it X by like 20 centimeters, and then I move it like this, and then it's a little bit intercepted with this that I can do this. So now I have my ballast base with this, and the next thing that I need to do is actually putting in a ballast block with this. So we will use the ballast block like this, and you see this ballast block in here. If you have this, it's has also this like base in this. So if I'm rotating it, I now can place this inside the drawing. The important thing that you now see when you do this, it also has this blue lines, and these blue lines are basically to put it on the different thing in here with this so that they are connected. Wait, I need to rotate it. I shouldn't have rotated it. It needs to be like this. So now I'm selecting this, I'm pressing the move key. I want this point, so I need to select the endpoint snap in here, and then I want the nearest snap in here with this. Where do we have it? This one, and then I want to patch it to the other blue line in here. So I have it in here, and now what I'm doing is I'm moving this. I want the intersection, so this one, and I want to move it to the end of the line, so this one. And now this ballast that I have in here automatically will be part of the calculation. I can take in the ballast like 1,500 kilos, pressing enter, and then it will actually add these 1,500 kilogram ballast to the structure. You see immediately this also increases the workload in here. So now you see that actually the problem is now the O point on top of it, so that you've placed it in here. So that is basically how you can calculate ballast and place this in here so you can make multiple bays. And the idea is really stay to the real thing that we need in order to calculate this. There are two more things that I want to show you. One is the wind load integration for planes. So currently, when you're doing it like this, basically only the tubes actually generate wind load. But that is not always the thing that when you want this. So what I will do is I will disable this, and then you see the deflection. I will disable this, and you see actually the deflection goes away again, and you see only because it's a little bit heavier on this side, it will only go in this direction. But now I want to draw a plane for this. The easiest way to do this is to go into the side view, and in here, click on the button that Bert already showed, which is user coordinate system to view. When I'm doing this, it will automatically align my coordinate system to the view, and I'm able to create a polygon from this. So I click on the draw 2D, I go to the polygon, and I say I want one structure from here to here. When I'm now doing this, I have my polygon in here that I can use. It's not the full area, but I think it will work for our purposes. That is something that I want to use as a wind load plane. So this polygon should be covered. In order to do this, I need to set it on the right layer and make a block out of it. If you go to File Settings and go to the structural, there's all the layers that actually are used for the calculation listed. The important thing for us now is the load layers. And in order to make this a wind load, you need to put it on the layer PA wind load. So I click on plus, I type in PA minus wind space load, enter. And now I need to select the polygon again because that's a bug in Brick SCUT that you can't do this like this. And then I go to PA, and in here it's PA wind load. Not sure if this was good enough. PA wind load, why is this frozen? Turn it on with this. And then make a block out of it. I'm not sure with the spelling because it's not. Wait, let me quickly fix this. That it's PA and it's big, just that we don't have this. So selecting the polygon, make this a block. The insertion point is not really important. I just call this wind load, enter, and the insertion point could be any. And if I'm now pressing on OK, you will see that this block is now part of this in here. And you see immediately everything now here is overloaded with this. So I don't have in this direction from the wind load in here some diagonals. So that's why it doesn't really like it with this. So by default, when you're doing this, the CF value from this is 1.8. So basically the area, which is currently 63 square meters, will be multiplied by 1.8 in order to actually calculate the wind load area. That is the worst case CF value that you have. So normally the CF value would be something like 1.3 for these things. Or if it's like a plane that actually lets through the wind, it could be also like 0.5. And then you see every time I'm doing this, it reduces the deflection and the pressure on the structure for this in here in order to calculate it. So now a long talk about this. Now let's have one last view on how to actually get the calculation report. So if you click on File and if you click on Create Calculation Report, you're able to create a report for this. There is two reports, and simple and expanded. We will only have a look on the simple export. So there is proof hoist, drops. We don't need this. We don't have hoist. We don't have drops. We do have ground supports. We want to add the wind loads. We don't want to add the floor loads. And I type in a project description. Now pressing on OK, going back to Brick SCUT, it asks me to save this. And I want to save it to the desktop, demo test, save. If I'm now generating the report, it opens on the other monitor with the Foxit, yes, no. And it creates a calculation report like this. So it puts in an image of the structure. Let me make this a little smaller. A QR code where you can access it online, a a table of content, the actual information, shows you the safety factors that it's using for the different thing. It shows you the load overlay, how much each thing actually weighs. It shows you the wind pressures at the different heights in here with this. And it shows you the wind load areas that has been calculated for this. And then for the ground support, so how much pressure actually in here is on the actual thing in here. It shows you the ballast for this, how much is this. It shows you the diagonal, so how much pressure or tension is in the individual one, so how much it can take from this, and then basically puts this in here. So if there's something wrong, for example, in here, you see the problem is that is actually overloaded in here at several points, it will do a stop sign in here. So that is not really good to do it like this. Let's say it like this. So in here currently that is the O ledger with this, and you see the problem with this is really that you have too much bending moment on this, which is really clear because we don't have diagonals inserted in this. So going on with this, and it prints in all the proofs for all the different cross section and puts in the FEA appendix. One word about the accuracy of the calculations. So Production Assist is a tool. In other words, Production Assist doesn't know what you're doing. So it's really easy, especially when you're doing outdoor wind calculations, to guess something's wrong. A typical thing is the CF value because it is not really like natural to people that are not on a daily basis involved with structural calculation. So if you type in the wrong CF value, you can get into a lot of troubles. In other words, what we recommend is if you're not really sure how structural calculations are working, I would always ask an engineer to check this. You're lucky in here, so we have a built-in engineering office. So Production Assist has an in-house engineering office, which just is doing structural calculations all day. And the nice thing is that you automatically have this integrated in your software. So if you click on here on the check structural results in here, it actually takes this over and gives you a quote how much this would cost to table this with our engineering office. The nice thing is you don't need to redraw it. You don't need to do anything. You just basically need to table it in here. And normally within one working way, you get the signed structural calculation from us where we take over the liability. So our recommendation in here, especially if it's outdoor, is get someone to check this. It doesn't need to be us, but it can be us. So that's the way how you would table it with this. That's the introduction into our production thing in here. So my question is, are there some questions? I would start from what I see in the chat, and then from there on, you we also you can unmute yourself and ask a question. So the first question that we have is, can you draw scaffolds and trussing in SCAD Re-event? Yes, you can do both. Basically, it's always the center lines of the beams that need to be added. So there is some overhead for preparing the blocks. We are currently in the process of doing this together with Bert, so that all the blocks in the SCAD library automatically work. But then basically you can calculate any type of beam structure and do the calculation for this. Then there's a question from Tillman. What about Mac? Metric. We can create, so I think we do have a metric system with this. So we need to update the library. So that's an ongoing effort with this. So every piece basically that layer has, or that any other piece has, needs to be done with this. So the library is every day is being improved. Then there's a system from Tom. So that's a wind load module also, but other. So yes, so basically we support any country that so out of the box, we currently support Germany, the Netherlands, France, England, and the US. So in there we have put in the effort to actually calculate this and to do this. When you're now in a different country, you need to check in the load yourself. So the easiest way to do this is, for example, when you go to global wind zones of Romania, according to Eurocode, you can have a look on this, and it actually shows you the wind load maps of different countries in here. Almost a complete world is in this software, and then you just need to type in this 0.5 kilonewton in the right value, which in this case in here would be in the way of thing in here. So if you want to be in the 0.7 region, you just go in here and point in 0.7, and then you're good to go with this, and all the other thing is the same in here. So can the user add static information to their own parts? For example, yes, that's a question by Stan. So I stop sharing my screen and go to the other one with this. So it is a little bit like Bert already showed. So the important part that we have with this is actually the structural lines in here. And these are on the layer. In this case, when I'm searching for it, 901, that layer static. So turning this on will show this. So what I need to do as in my own world in here, in my own symbols, is basically add these center lines in here. So on a really basic level, double clicking and then drawing these lines in here so that I can use them for the calculation. There is a specific way on how to map the cross section. So I already showed you the settings, and in there basically for a specific given layer, you can define the cross section that should be used. Sometimes you don't want this, so we use colors for some of the parts. In order to see the colors, you need to click on Window, Resource Manager, and in the Resource Manager, there is the, where we have it, is the cross-section templates. And in the cross-section templates, we have the complete list from all the cross-section that we do support. So it's quite a lot of cross-sections that we have. I think we are like 700 currently with this. So I can search for a layer, for example, in here, and then the layer, there is a color map. And if I'm clicking on this, it basically gives me what kind of thing this is and what is the color that I assign to it. So the color of an object plus the layer actually generates the cross sections. So any type of cross section that you have in here can be done like this. I show you something out of our engineering office when I do find it. I think this is the one. So this is a stage that has been created by the layer symbol. So layer itself created it for one of our customers. And what we've been doing in here in order to get this working or to make this a reality for us is actually generating the right lines with this. So we have a look on the tubes in here, so on the railing system. So, and for this, I need to make this, and now where do I do this, that I have the wireframe view. You see, when I now double clicking this, I'm already editing. I'm already editing it in some. I already have this in here. Close. Sorry for this. Double clicking. And then you see what I actually did in order to make this calculatable is I have added all the all the lines from the different cross sections in here. And I think now when doing this in here, I'm not sure what the status with this drawing is, but if I'm now going into the production assist and do the enable production assist, I also can read in this drawing. Yes, and it's possible. And then you see it has all these different things in here with this. So all of this connections and stuff, they are also supported with this that they do. It's even possible somewhere in here they have where do we see this? They have tubes in here, and also this tubes and this clamps can be calculated with this in order to come to the right base. Or the multi bases, they are also part of our software, so that you can. Sorry for this, that you also can calculate the multi bases. So going back to the thing, so there is nothing in the chat anymore. So do you have any? You said you also can. Yes, it is working the exact same. So the question is, you said that we can also calculate trusses. Is this working the same way as Scaffolding? Yes, it is. Basically just insert the truss and then it's working the exact same way. Then, if there's no questions, I just end the thing. Thank you so much for your time. It was a pleasure showing you to this. Give it some 1 hour or 2 in order for the recording to process, and then you can use it and watch it. So thank you very much. Bye-bye.
Thank you, Moritz.